Ich brauche noch LibreOffice. Das PDF war nur zur Sicherheit, falls es nicht kannst.
LibreOffice ist da schon.
Ja, alle mit LibreOffice.
Okay, hey everybody on YouTube. This is our live stream from Vienna, from the TYPO3 camp in Vienna. We'll starting with the next session in 2 minutes. I ask for some patience. Thank you.
Ist das? Ja.
Also wäre es so weit einrichten, dass er das anzeigt. Presentation.
Das da, ne? Ja, genau. Du musst dich daher setzen und so reden, dann hört man dich da. Und
Okay. Die wahrscheinlicherweise auch.
ja, genau. Sag Peter, du bist soweit.
Peter, ich wäre soweit. Peter?
Just a minute. Okay, everybody, welcome back. And I like to say hello to Norbert, and with a session on GraphQL, and JSON REST API. Welcome, Norbert, and go ahead. Your stage.
Hello, Peter. Thank you very much for your introduction. Today I would like to talk a little bit about GraphQL and JSON REST APIs. Because at the moment, or in the last 2-3 years, especially the progressive applications started to grow up, and they all need data from the backend server. And JSON REST API and GraphQL are the most promising or most used ways to retrieve data from the backend. First of all, a little bit about me. My name is Norbert. I'm from the aimeos e-commerce framework, which is, well, a complete e-commerce framework which is integrated into TYPO3 as TYPO3 extension. And the reason why we are using APIs is, if you have a little bit a look at our development stack or our tech stack, you will see that the gray areas, backend application, front-end applications, this is TYPO3 in our case. And at the top, you will see JSON REST API, the HTML, CSS part, and on the left side also the admin JSON API and the Vue.js backend. And after the rise of GraphQL, we took a deep look into if we should use it, for example, for the front end, if we should add it as an additional alternative to the JSON REST API, and make a comparison between both to see what are the advantages and the disadvantages of both APIs. If we look at GraphQL first, if you don't know, GraphQL was invented by Facebook, which means they use it to connect to their backend and to fetch everything you will see in the front end regarding newsstream, friends, images, and so on. And Facebook is a graph of data, which means you have the nodes, which are the people, and the connections between the peoples are the graphs. Facebook invented GraphQL because they need a way to efficiently retrieve the data from the backend. And this is also the main use case for GraphQL up to now. It makes it possible to retrieve data using complex queries. That means you can deeply fetch, for example, related resources and filter them by various restrictions. It also was a design goal to minimize the response data. That means to fetch only those data which is really necessary in the front end. So, for example, don't fetch metadata, but only the name of the persons and not much more. If we have a look at how queries of GraphQL look like, you will see it's a rather simple structure of the resources and the related resources that should be fetched. In this case, we have a product which should be fetched, especially the name of the product, and the media URLs, which means images, for example, in this case. So response is a JSON response, which includes the requested resources, here the product, and with its name and the media URLs for the images, for example, here the images of the product. GraphQL has a lot of major advantages which made it very successful in the last 2 or 3 years. One of them is we have one API for all your client requirements, which means the GraphQL can also work as director for different resources, meaning you can, for example, fetch products, fetch suppliers, or everything else which is in context of a CMS system, or in case of Facebook regarding connections to other people, and so on. Also, for example, I think Facebook uses it for fetches ads and resources that are not directly related to the stream of news. It also is very efficient regarding included resources. So, like you've seen in the example, you can fetch not only the resource itself, which was a product in our case, but also all the related resources like images, texts, prices, and so on. I use the example of the products here because natively we are working with those kind of data in our application. In case of TYPO3, you have to think about pages, content elements, images, texts, and so on, which are managed in the backend of the TYPO3 application and displayed in the front end. You can also retrieve data, only the data you need. Like in the example, we've only retrieved the name of the product and the URL of the image items. You can limit that exactly to what is required by the front end to display, and everything else is filtered out on the backend side. Also, writing several resources at once is really simple because the complete mutation statement can contain mutations for not only the product, but also the related items, the texts, images, and so on. And you only need one request to store the data in the backend. The exact definition of the schema is also provided by the server, which means that when you send a request to the server will return the schema that is used by the resource and which is available, and also how you can filter these resources. For example, a schema would look like this. You have a type product which contains an ID, a label, and a status, and each of those fields have type, a specific type like ID, a string, or a boolean. It also supplies a very well-defined query language, so you can you don't have to think about in which way it can be queried, because the query language is defined and fixed in the specification of the GraphQL. A query can look like this one. This is almost the same as what we've seen in the first time regarding the query for the product and for the media images. But in this case, we also filter the product by a code with a value and the attributes by a specific type. On the client side, there are many libraries available, and the most successful or most often used one is the Apollo library, which, especially in case of the Node.js environment, is almost used all of the time, I would think. And so it makes it very easy to query and update resources for on the backend side, which provides a GraphQL interface. But there are also some disadvantages, as you would think, because first of all, due to how Facebook invented the interface, they don't need much caching, because everything that is retrieved from the backend server of Facebook is because the client is logged in, and they fetch the personal data from the Facebook user, which means there are no intermediate caches like CDNs or something like that. And the GraphQL specification makes it very difficult or almost impossible for CDNs to cache the queries of GraphQL in between, because the GraphQL queries are sent in the post body of the request instead of, for example, the URL itself. And as you may know, post bodies or also everything that is posted to the server is usually not cached by any CDN or any in any browser cache. Also, optimizing queries can be very hard, because if you remember how queries are done, the complete schema can be used to create queries in very different or for very different data, which means if you only change one field and say I want to include that field or I want to leave that field out, it changes the query itself. And filtering for the data is also possible by all of these fields, which, especially in context of a database, makes it very difficult to optimize, because you would need to have indices for all kind of data and all kind of combinations, which is usually not possible. Therefore, the GraphQL people say, well, see what the clients are requesting and then try to optimize for it and later on. Another problem is that GraphQL clients can build very deep and complex queries because they are not limited by anything regarding how deep you can request, for example, related items. To get a little bit around that, GraphQL forks usually will tell you that you need to break up queries after a certain level. So, for example, only retrieve 5 levels of related data, but not more, because otherwise it's easily to overload the server and to create a denial of service attack. One other problem is that the client and server are very tightly coupled, because whenever you change a field in a database, rename it to something else, the clients still depend on that, because the queries are more or less a direct representation of what you have in the database. More or less means this is usually the case if you don't have any abstraction between, and therefore, whenever you change something in the database or on the server, it directly hits your clients. And especially when clients are, for example, mobile applications you can download from the app stores or something like that. It's very hard to keep in line or keep them up to date, because whenever you change something, you have to change the app, and to make a new version, you have to upload to the app store, and all your users have to install it before you can really change the field in the database. And in between, we have to do some transformation. So thus, the tightly coupling is usually a very big problem. Facebook doesn't have that problem because, say, the data shown in the front end are a direct representation of the graph in the back end. And whenever they change something, they only, or the front end is updated automatically, because they use in the latest version progressive web application that is downloaded or used whenever you log into Facebook. Another thing which is not very well in GraphQL is that the application state must be totally maintained by the client. You might say, okay, that's quite normal, but I will show you later on in the JSON REST API a way to decouple the client and the server a bit, and to show you a way how you can how you can provide the application state to the client without the need to put everything into the client code. And last but not least, the query language adds another abstraction or another layer of complexity. Even if the examples are at the moment, or what I've shown, are rather simple, they get complex, or they get complex very quickly if you work in real time or real life projects. So at the end, if you want to fetch something from a GraphQL interface, you would have something like that. For testing, you have to send a post request JSON data to the GraphQL endpoint, and the query needs to be in the body and looks like this, like a query product name for the product name. And you will need client-side caching for sure, because of what I've said, that caching by CDNs or by other systems in between is not possible. And adding caching on the client side in the browser, for example, you have IndexedDB or whatever else that's cached, and the worker threads for the progressive web application also offers caching, but it provides, or it introduces an additional point of failure that may be hard to debug. On the other side, the JSON REST API is much older. I think it's from 2013, 2012, 2013, and was originally invented by the Ember.js team. Don't know if you know Ember.js well, but it was the first JavaScript, or it was one of the first JavaScript frameworks that provided a complete environment for developing single-page web applications and so on. And now React and Vue.js are much more popular these days. The goal of the JSON API was to reduce the amount of code on the client side, especially avoiding much boilerplate code, for example. So the client side and the server side code should be as easy as possible, and this is also noticeable if you look at the JSON REST API and how it is structured, and how it can query, for example, for resources. And they try to use as much best practices that have been available at that time, like, for example, the REST principles was already available. So you have the representational state transfer using the HTTP protocol, including using headers for caching and for accepting data, for example. This is all part of the JSON API specification. If we have to look at the query, it looks much simpler than the GraphQL example, because we only have to say it's a JSON, what we expect, or what we send and what we expect, and we have one endpoint which is clearly defined by the URL. And each resource, like here the product resource, has a unique endpoint for the JSON REST API, or in this JSON REST API specification. The response is pretty similar to what we've seen for GraphQL, but it contains a little bit more data. Especially each entry in the response contains an ID and a type attribute, which means it is almost identifiable by the ID and the type that is provided at the top level. And in the second level, the attributes contain all data that is sent by the server. Here, for example, we have a UID, we have a code, and we have the name of the product. The advantages of the JSON REST API are you can also, or like in GraphQL, you can also efficiently retrieve related resources, because you can tell the server in the URL that you want to include or do you not only want to get the product back, but also includes the price or other related resources, simply by adding the ampersand, include, equals, and the resource you want to fetch from the server too. The response itself is similar to GraphQL, but not the same. It's a little bit more difficult because you have, regarding ID and type and attributes, also a relationship section which defines what are the relationships or what are the related resources in the response and what's their ID. And the entries itself, the related entries itself, are added to the included section. This has one disadvantage when comparing to GraphQL, because in GraphQL you have the complete structure which is within the objects and the sub-objects, but it also has one very important advantage, because if products, for example, share a resource, like in our case attributes that can be shared by several products, the attribute definition itself and the attribute content itself has only to be included once in the included section. So this will reduce the amount of data transferred from the server to the client very much if we have a lot of related resources that are shared. Like in GraphQL, you can also retrieve only the data you really need. The example shows, for example, the product example, retrieving the product with the fields given and named ID and name. So it will only return the fields ID and name in the product results. I think the biggest advantage of JSON API is that it can be cached by CDNs, proxies, and browsers. Because this makes it possible to scale such a service almost infinitely. Compared to GraphQL, where we have to add a lot of servers to handle the requests, it's possible by adding cache headers on the server side to say, okay, this resource or this response is valid for 5 minutes, 1 hour, 1 day, and all CDN or proxies in between the browser and the server will cache it and will return it instead of asking the server again for each request. Contrary to GraphQL, client and server are more decoupled when using JSON REST API, because it's not really a direct representation of the database content, because you have the possibility to do some kind of abstraction here, and to, especially for the related resources, you can it's simply no direct representation, I would like to say. So it's more decoupled and more easy to update or to change something in the backend, which doesn't affect the front end immediately. And like said in the GraphQL example, the application state can be more managed on the server by GraphQL, because if you have a look at this example here, there's a principle named aimeos, the hypermedia as the engine of application state. which means the JSON REST API contains a link section that contains all links of what is possible next and what the client can do as next steps. For example, here in the link section, we have the self link, which means this is the link which will return the same response. Then we have the next link, for example, telling the client if the user wants to retrieve the next product, please use this URL to retrieve the response. And last but not least, you also have a URL how to add the product to the basket. And this is not available in GraphQL. So it makes it easier for the client or for the programmers, developers of the client to know what they have to do next or what they can do next and how the resources are retrieved. The queries can also be optimized in a better way because we have or the JSON REST API offers the use cases you have implemented. And so you can much more optimize the backend based on the queries that will be sent by the clients, which are not the complete representation of the database content and the database fields. So it's more, or it's easier possible to use, for example, filters in JSON REST API, or to offer filters for the resources in the JSON REST API that returns or filters for different conditions, and for these conditions it can be optimized. And the API interaction is really plain simple, because like you have seen in our first example, we only have one URL that contains the resource endpoint, and you have to add a few parameters, for example, to include related resources and to limit the resources by fields, or to filter by certain conditions. But everything is in the URL, and building that URL is really plain simple. So back to the disadvantage section, which is also available for JSON REST API, for sure. And one of the biggest disadvantages I've seen, or I've noticed when using the JSON REST API is you can only update one record at once, because in fact each record or each resource has its own endpoint. And for example, if you want to update not only the product itself, but also supplier information, you have to do at least 2 requests to the server updating the product first, and then the supplier afterwards. This also means that you can't use or you can't have transactional safety to include both transactions into, or both operations into one transaction. And especially updating several resources is much more difficult than in GraphQL. The JSON REST API specification also doesn't have anything, or doesn't specify the query language in any case. They leave it up to the application developer to say, okay, if you want to filter something on the server, please use that kind of query language. So you can have very different query languages in one project if you're using several endpoints or several JSON REST API services, and each one has its own kind of how to filter the resources. So it can be a mess if you're using several services at once. Also, contrary to GraphQL, the server doesn't return any schema, and this means that you have to document the schema somewhere else. And like we all know, documentation can be quickly out of sync with implementation, and it might be a minor disadvantage, but I think the schema would be good to have in JSON REST API 2 to ease the life of developers, because whenever they request something or ask the API, they can immediately see what they can do and how they have to send the data, in what format, what kind of filter, and don't have to enter. The server also checks against that schema, which means that if the client sends something wrong, the server can immediately return with an invalid schema exception, for example. Because the JSON REST API doesn't have that, you don't have that kind of schema validation. You have to implement that yourself on the server side, which can be a daunting task depending on how big your API is. So the conclusion from my point of view, from the e-commerce point of view, and also from the CMS point of view, because they are very, very similar, both manage content. The e-commerce content is usually a little bit more structured because you have products and related data. In the CMS context, you have pages, content sections, and so on. For GraphQL, it's best used for internal APIs, which means you have an authentication and the API is not publicly available because you avoid the problems that malicious user can build deep and complex queries to overload the server. And you always know what happens because if you have implemented the client too, you know exactly what queries will be sent by the client and how you have to optimize the database to retrieve the data efficiently. It's also a perfect endpoint for clients, regardless of if there is only one endpoint or on one API, or if several APIs are covered by the GraphQL interface. So for example, if you have several services in your company and want to offer those services to an application you're using in a company, then the client doesn't need to know where is the service, how can I find the service, what if the service name changes, for example, but you can only connect to the single GraphQL endpoint, and the GraphQL interface or API will act as director between the different services in the background. The downside is the lack of scalability, because like I said, caching is not possible or almost not possible. So GraphQL folks try to do caching on the server side by hashing the query and see if the query was already executed in the past and returns the result or the cache result instead of asking the database. But that's all. Yeah, that's a workaround. That's not really. That's not really the solution. On the JSON REST API side, we have clients and servers which can evolve independently, which is a very big advantage if you have public APIs that are used by different developers all over the world implementing different applications where I don't have control over the application itself. And it can scale almost infinitely because of the CDN and the proxies in between, which can act as a layer for additional caching and distribution of worldwide requests. The downside is I wouldn't use it for write-heavy usage, like stated. If you have to write a lot of data in your application, like in our case, it's the administration interface, where editors can manage product content. It's a little bit of a pain to use the JSON REST API because you have to update all records once, all records, or every record in one request, which leads to a lot of requests, and due to the network latency, it also takes much longer than it should be. So that's for the aimeos, or here a little bit of the aimeos decisions. What we've made is we already have a JSON REST API for the front end, and we will keep them, or we will keep the API because the advantages of having a public API is that is scalable is very much of advantage for us in the front end of e-commerce, because it's simply a problem if your API doesn't scale and will crash your server. We also decided to use GraphQL, but only for the admin backend, because here we have a controlled environment like Facebook has for their side. We know what requests might be coming and what data we can expect, and also if the users or the editors are authenticated, so we have the public API which can be used for denial of service attack. These are the reasons why we decided to use JSON REST API in the front end and want to switch to GraphQL in the back end. So, thank you very much for your attention. And if you have any questions. Yeah, please start.
Okay. Do you have any experience with using PHP as a client for GraphQL? What do you use there? I mean, of course, you get JSON, which you can parse, but I mean something more advanced, where you get like ready set data models or something like that.
Yeah. The question was if there are PHP libraries available for working with GraphQL, and the answer is yes. On the GraphQL side, there is one very popular one, I think. PHP minus GraphQL, I guess, I think is the name, and which makes it much easier to work with the query language, which is a big plus point. Nevertheless, in context of, for example, TYPO3 with X-based models, it would make more sense to offer a more specialized PHP client, which is directly working with the models itself. Other questions? Not here. How is the online?
We'll see. Anybody online who has a question? No, it seems not so.
Okay.
So,
Then
Norbert, thank you very much.
thank you too for hosting.
And again, we'll stop the live streaming right now and the recording right now. Everybody who's online in Zoom is welcome to have a chat, and we'll see each other in the streams in, let's say, a quarter of an hour for our next session. Thank you very much.
Thank you.